software quality guidelines. How to focus on what matters the most. This is a VALA guide for quality leads and business representatives to determine what kind of quality aspects to focus on in a software development project. The guide can also be used as a basis for quality strategy planning or reassessment. In this guide, we'll explain all the quality aspects there are in a software product and in its use, and how they can be taken into account not only in testing but throughout the whole software development lifecycle. Why is it important to define quality goals? You probably want to align the development approach with the business goals. But as quality is not one solid thing, it needs to be defined what it means in this case. What quality aspects are important in the current context and for the target users right now? What should be focused on? What quality aspects are already taken care of sufficiently and what can be left out? This quality goal definition is best to be done at the planning stage of a project, but it is also useful when planning the testing of a product or whenever there is a good spot to step up with quality in a project. In practice, if these quality aspects are not considered with the business stakeholders and the team developing the product, non-functional quality aspects are overlooked in design, development, and testing. When these quality goals are defined together, the importance of non-functional requirements can be appreciated more by the stakeholders. This is why we recommend sitting down with the business representatives and the quality manager to agree on the quality goals of the software under development. We hope you find this guide useful in your quality work. Special thanks to Esa Hakulinen for co-writing the security chapters, Johannes Heikkinen and Mari Hänninen for proofreading, and all Bala M-Hub test management community members for the bug examples. High-quality software leads to a high-quality user experience. There are plenty of software quality definitions to pick from. One good example of a definition is the following. Number 1. A software that fits well into its purpose and to its user groups. Number 2. Something that makes the users feel efficient, happy, and productive. Number 3. Optimized usage flows, avoiding unnecessary steps. Number 4. Or something more precise, such as accessibility, where the software is designed, developed, and tested in terms of making the software usable for people with disabilities. There are 3 categories of quality measures defined by the ISO/IEC standards: quality in use measures, measurement of system and software product quality, and measurement of data quality. These quality models serve as a framework to ensure all characteristics of quality are considered. These quality characteristics will be explained in the following chapters. How to use software quality aspects. This guide concentrates on explaining product quality, which leads to quality in use, and how it can be taken into account in quality work during the software development. Note that this is not a template that needs to be filled, but a supporting document in your quality strategy work. You can use this guide as a product owner in defining quality priorities, or as a quality manager in defining quality strategy, or in any position where you need to plan and prioritize your work in software development. This guide is in best use when you consider these quality aspects in good cooperation with the business-oriented people who may find it difficult to articulate their quality goals in such a detail that it can guideline the way of working. Define software quality aspects with following steps. Number 1. Identify on a high level what each product quality aspect means in your system or product context. Number 2. Prioritize these quality aspects in running numbers together with the stakeholders of the system under development. Number 3. Choose 3 to 5 aspects to improve in the next development phase in the current software development lifecycle. Number 4. Specify and explain how to improve the quality of the chosen aspects in your quality strategy document. If you plan your work based on these quality aspects, you are more likely to be working on things that matter the most, and your quality-related decisions will be well justified based on business needs. Number 2. Functional suitability. Functional suitability is a quality aspect which considers if the product suits stated and implied needs of the user when used under specific circumstances. Functional suitability consists of functional completeness, functional correctness, and functional appropriateness. Functional completeness refers to software covering all related tasks and users achieving their goals. Functional correctness refers to correct and precise results of functionality. Functional completeness and correctness are probably the most well-considered quality areas, as functional specifications and testing is the main approach in many projects. Appropriateness refers to software suiting well in situations where the software is used. Functional appropriateness is at risk of not being considered in the testing phase, but is as important as the 2 characteristics above. Can the software really fulfill the needs of its users? 2.1. How to use in quality management. Some of the basic questions to consider regarding functional suitability are: is the future ready so that the user can complete the specified tasks with the software? Do different input combinations produce correct results? Does the software have all the important features? Does the software function in the way it was designed? The design functionality is often well covered in either future testing or test automation. By whom and in what situation is the software used? Does the software suit these different user groups in their varying usage flows? This is best covered by exploratory testing, done by a tester with an open mind and understanding the mindset of the users, or acceptance testers with strong context knowledge. 2.2. In the eyes of the user, effective and suitable usage. When the software has good functional suitability, it makes the use of the software effective and well suited to the situation it is used in. This leads to the following user experiences. Number 1. Feeling of accuracy and completeness. The user can achieve specific goals in a way that feels right to the purposes of each user group. Number 2. Context completeness. Feeling of getting things done. The user doesn't get stuck before the goal is reached, and the use is effective, efficient, risk-free, and satisfying. Number 3. Flexibility. The user can use the software in new situations beyond the specified context. Number 3. Reliability. Reliability is a quality aspect which tells if the system does what is specified and behaves in an expected manner in its environment. Reliability consists of maturity, how finalized the system is. Availability, system and its parts are available for use when needed. Fault tolerance, system can be used even at failure situations. And recoverability, how well the system recovers from a fault or interruption. 3.1. How to use in quality management. System maturity can be followed in the development phase by measuring the test coverage and the ratio of how many issues have been fixed out of all found issues. It is rarely measured in development environments, even though it could be a significant issue in slowing the development speed down. But typically this is measured in production monitoring. How often is the system available when it should be available? How long is the system down when a failure happens? Fault tolerance can be revealed in exploratory testing, where the system is pushed over the limits of normal use in order to find faulty situations and how the system can be used despite these errors. Recoverability can be improved by creating a proper backup data updating process for the production use, but also monitoring how long it takes for the system to recover from a failure. Number 4. Compatibility. From the user perspective, compatibility appears as smooth usage, disregarding whether the usage flow runs on only one software or many. For example, when a user is buying something from a web store, the money transactions are handled by third-party systems without the user having to put in any payment details manually. Compatibility consists of coexistence and interoperability. Coexistence means that two or more functions or systems share the same resources without mixing things up. Interoperability means that the interfaces between different systems work well together. Interoperability refers to different programs exchanging information, sharing files, and using the same protocols. 4.1. How to use in quality management. Compatibility needs to be specified properly. What interfaces do the components or systems have? And what kind of communication is supported between them? If APIs are well specified, they are more likely to be utilized also in testing. Test environments need to provide the actual dependent systems to be utilized. The dependent systems are too unstable in development environment or for other reasons can't be utilized in testing. The dependent systems need to be mocked well to replicate the interaction with the system under test. However, if dependent systems are mocked out, it can lead to quality risks due to uncovered features in the mock or changes in the actual systems. To ensure good compatibility, it is important to do sufficient platform testing, component integration, and system integration testing and/or API testing. Number 5. Portability. Portable systems can be installed and used in different environments, or they can replace similar systems. Portability characteristics are adaptability, installability, and replaceability. Adaptable systems can be transferred and installed easily from one platform to another. Here's a list of example target platforms where a portable system can easily switch between. Changing operating systems, updated operating system versions, different browsers, or pointing to a new interface used by the system. Installability measures how effective and easy it is to install the software and software updates in different platforms. This is important when developing software that needs to be installed by the users. Replaceability measures how easy it is to replace the software with another similar software. This needs to be considered when one component is changed in a large system. 5.1. How to use in quality management. Portability can be evaluated by testing how easily a software can be transferred and installed from one platform to another. To avoid huge costs in hardware, testing can utilize cloud-hosted test farms, where the test can be run on multiple real-life devices. Replaceability can be evaluated with these questions. How similar is the usage of the new software? Are the possible APIs similar? Can the software fit well in the overall functionality of the whole system? So the overall usage of the system would stay the same. Are changes in the data needed? Number 6. Usability. When a user can use the software easily the way they want to and even feel satisfied while using it, the software can be considered usable. However, usability consists of many different areas. Appropriateness and recognizability, learnability, operability and user error protection, user interface aesthetics, and accessibility. Appropriate software meets the user's needs. It fulfills the tasks the user has to accomplish and does it in a way the user expects them to in this context. Recognizability relates to a new user recognizing if the software would fit their needs. Learnable software is working in such an understandable way that it provides an intuitive way to accomplish user goals without having to read loads of manuals. Operable software is easy and consistent in use. Customize own views and undo selections when wanted. A user can also control how to use it, for instance, operate it with a keyboard, mouse, or voice commands. Moreover, there can be messages, such as pop-ups and tooltips, to guide the user forward. For example, if there is a summary of user selections, a user should be able to adjust the selections before proceeding. User error protection consists of features preventing a user from making errors. Impossible options are disabled, incorrect inputs are not accepted, and a user can recover from errors easily. User interface aesthetics enable pleasing and satisfying interaction to the user, and is strongly related to the consumer product's brand and wanted visual look and feel. Accessibility means that users with different characteristics, such as native language or disabilities, permanent, non-permanent, or situational, can use the system without difficulties. For example, if a user has color vision deficiency, it can make using the system more difficult with certain color combinations, or visually impaired needs to use voice commands. Accessibility is one of the primary outcomes of inclusive design, which focuses on making solutions usable for everyone, regardless of their conditions, environment, or abilities. 6.1 How to use in quality management. To be able to predict in the development phase whether usability is sufficient, it is important to have a comprehensive understanding of the target users, their abilities, and what purpose they mainly use the system for. This understanding can be gained by user interviews, by following their system usage, by collecting usage data from production, or by discussing with someone from the business with deep customer understanding. This understanding is then utilized in exploratory testing of a certain usability characteristics, for example this way. Thinking about what the user wants to accomplish and working through the software through the user's eyes. Using a tester without prior knowledge to test learnability. Exploring the consistency of different use flows and that the software prevents a user from making mistakes. The look and feel of the user interface is pleasant and consistent with the design. The core features can actually be operated with, for example, a reading device. UI test automation can be used to ensure operability and error handling, but also unit testing is often the best level to ensure basic operation functions and graceful error handling. 6.2 In the eyes of the user. Usability leads to satisfied users. Usable software makes the usage of the software well-fitting, or simply stated, it is usable. Usability answers to the following questions. Satisfaction. Is the user feeling good interacting with the system and having an overall positive attitude towards the system? Usefulness. Does the user feel the goals are achieved, including the results and the consequences of using the system? Trust. How confident does the user feel that the system will behave as intended? Pleasure. How well are the user needs fulfilled? How pleased does the user feel using the system compared to other similar systems? Comfort. Is the user feeling physically comfortable using the system? Uudestaan. Comfort. Is the user feeling physically comfortable using the system? In production, user satisfaction can be clarified by interviewing users, following on one user, gathering feedback, or by monitoring and gathering trends on, for example, these items. Amount of users per feature, the more popular, the better. Amount of users leaving the process before finishing tells of poor usability. Complaints per feature, users with complaints / all users. Support requests, uudestaan. Support requests / all users. Number 7. Performance efficiency. Performance efficiency measures software's time behavior and resource utilization. Time behavior evaluates if the software provides appropriate responses to requests within a reasonable time frame, processing time, and if it can handle enough of such requests and responses, throughput rate. The most important core functionalities needs to be very fast, but more rarely used functions don't usually need so much optimizing. In production, resource utilization may cause significant expenses if you have too little resources, leading to unstable software, for example due to running out of memory, or too much resources, leading to high resource expenses in production use. In other words, if the system under development was a highway, processing time would measure the time it takes for one car to drive it end to end. Throughput rate would measure the amount of cars flowing through the highway in a reasonable time, and the resource utilization would measure the sufficient amount of lanes for the amount of cars using the road. 7.1. How to use in quality management. The acceptable level of performance efficiency needs to be ensured at the very beginning in requirement definition and architectural design phases. Some of the considerations could be: how many simultaneous users do we need to support? What is the median of usage load? Are there going to be some occasional or seasonal load peaks? Do we need to be able to scale the capacity up rapidly, or is the user volume more static? Which functionalities need to be optimized and which can be slower? Is it okay to cause a lot of internet traffic, or should it be optimized in the software? Measuring performance is best answered by a performance testing expert specialized in performance monitoring as early as possible. In addition, performance should be automatically and continuously tested against baselines throughout the project to ensure that changes do not suddenly cause degraded performance or sharp increases in resource consumption. Measuring performance just before the release leaves no time for adjusting a performance-critical system. When the limits of the system are identified, the software needs to ensure that too capacity-intensive actions are prevented, for example by preventing users from loading too large files into the system. More on software reliability in Chapter 6, Reliability. 7.2. In the eyes of the user. Adequate performance leads to efficiency of use. When enough resources are used to match the accuracy and completeness with which users achieve goals, it leads to a correct way of building the product to match the usage loads, and optimized core workflows make it easier to reach the most important user goals. When using a software with adequate performance, the user doesn't need to noticeably wait for the system to process the wanted functions, and the system doesn't end up in failure if the user does a heavy search or inputs a large file for system handling. 8. Security. Secure software keeps all the data and information protected from unauthorized use. Security consists of confidentiality, integrity and authenticity, non-repudiation, and accountability. Confidentiality means that the data or information is available for authorized and unavailable for unauthorized persons or groups. A failure in confidentiality happens when someone who should not have access to certain information or data manages to gain access. The confidentiality rules may come from company policies and agreements, but in certain domains, regulatory compliance defines many confidentiality rules by law. The term non-repudiation refers to the situation where a party can't deny the authenticity of their signature on information or the sending of the data. It also means that the author of the transaction is the only attributor to the transfer of information. Accountability means that the actions of an entity may be traced uniquely to that entity. E.g., accountability is met when unique user identification and authentication are used. The usage of shared user IDs and passwords destroys accountability. 8.1. How to use in quality management. It is beneficial to consult security experts on security-related issues and how they should be handled by the software. It is not very effective to only run a security scan before a release, as many things need to be implemented early on in the product lifecycle to make the software under development secure enough in the given domain. So adding abuser stories to user stories builds security characteristics in the software. Confidentiality can be tested in normal testing, ensuring only authorized user groups have access to the given features, and user-defined password is required to be strong enough. Integrity is suitable to be tested in white box testing. How well is the unauthorized access and editing prevented in the component or system integration level? It needs to be evaluated if the data is strongly encrypted or is the data lying around in natural language, easily read by anyone with access. Also, using well-established digital signature providers help in having non-repudiable service, if applicable. Accountability can be tested by making an action and seeing if it can be found in the system logs in a way that reveals the correct user in action. If data history needs to be saved, the earlier versions of data need to be saved in the database as obsolete versions. And this can be tested by changing the data and seeing the old versions in the database correctly. If security protection is vital, penetrating testing can be used to simulate an attack with an aim in unauthorized access in a more forceful way. 8.2. In the eyes of the user, secure software leads to safe software usage. When security factors are well taken care of in the software, it provides secure usage of the software to users. Security in usage consists of avoiding economic damage risk, avoiding health and safety risk, and avoiding environmental harm risk. So, when the software is secure, the user doesn't have to take economic risks using it. Also, the company's commercial property and reputation are better protected, which is important as issues in economics not only cause direct economical effects, but can lead to severe reputation turnbacks, leading to massive customer getaways for a long period of time. Secure software usage doesn't lead to health or safety risks to anyone. So, for example, a social networking application should prevent harassing others behind disguised identities, which could lead to severe health and safety issues to the person. Environmentally secure software does not, for example, enable the user to select to leak toxic waste into nature. 9. Maintainability. Maintainability is a quality aspect which explains how easy it is to update and change the system. It consists of modularity, reusability, analyzability, modifiability, and testability. A modular system consists of as independent modules as possible, and each module is not very complex. Reusable assets can be used many times, in different functions or as part of building other modules. Analyzable system consists of easily read and complete system logs to analyze, for example, production usage, and also effective diagnosis functions in the system when failure occurs. This is vital in error recovery in systems that need to be highly available. Modifiable system is easy to change. The work is efficient and doesn't easily lead to errors. Testable system is easy to test manually using the system itself and automatically with an external test automation software. 9.1 How to use in quality management. All of the maintainability issues can be avoided with proper technical design. Modularity, reusability, and modifiability can then be assessed in the code review before any code can be put into the main branch. To improve reusability, all code needs to be written according to agreed coding rules. Analyzability can be checked in testing, so there will be no problems in analyzing urgent production issues when they arise. Testability is also a factor that needs to be assessed before the actual testing begins. Quality manager needs to consider, for example, these questions. How complete user flows can the testing cover? How independent is the testing from external systems? Or can they be mocked out? Can the system tests be automated? Are the UI elements and their properties available for the testing tool? What about APIs? And last, how easy it is to stop testing and have a fresh restart of the testing when needed.